How's it, grade 11? So we are going on to proving identities now, working from slides 108 to 114 from the trigonometry PowerPoint. Okay, so how do we prove these or go ahead by proving identities? You're going to be given like an equation and they're going to say prove the identity. You're going to work with the left-hand side and the right-hand side separately. And you're going to prove that the left-hand side equals the right-hand side. Once you've done that, therefore the identity must hold. Now, you're going to be doing a whole lot of stuff. If you've got fractions, you're going to be finding an LCD. You could be factorizing, and we've seen some examples like that already. So there's a whole combination of different things that we can use to prove these identities. Also, another thing, grade 11s, I want you to convert everything to sine and cos if you can. Okay, it'll make your life a lot easier. Also, what you have to use is your identities. We've just got the two so far, which is sine squared plus cos squared equals 1, and tan is equal to sine over cos. Okay, so let's go into example 1. They're asking us to prove this example. So this is A, and it is tan squared beta minus sine squared beta equals tan squared beta times sine squared beta. Okay, so sometimes there's a more of a difficult side to work with and an easier side to work with. How I approach these things is you can work with both sides or you can work with one side. It's really up to you. But like I said, what I like to do is I like to change everything to sine and cos. So on the left-hand side, we have this tan squared beta minus sine squared beta. And on the right-hand side, we have tan squared beta times sine squared beta. Okay, so what I like to do, like I just said, is I like to change everything to sine and cos. So that's the first thing I'm going to do here. So this is sine squared beta over cos squared beta using our identity minus sine squared beta, and this will be over 1. On the right-hand side, let's change this to a using identity to sine squared beta over cos squared beta times by sine squared beta over 1. I'm going to continue working with my right-hand side, and let's just simplify this. So we have sine squared beta times sine squared beta will give us sine to the 4 beta over cos squared beta. All right, so that is what I'm going to try and get this side to look like. So when you are adding and subtracting fractions like we are here, we need to find an LCD. And our LCD would be cos squared beta. So everything is going to be over cos squared beta. This one is going to stay sine squared beta minus this. I'm going to multiply up there to get our denominators the same. So we get sine squared beta times cos squared beta. Now, if you have a look here, it's looking something similar to it. We've got the cos squared beta at the bottom. We just need to now manipulate this numerator to look like something like this. So as you can see here, we've got two terms. We've got sine squared beta minus sine squared beta cos squared beta. I have a common factor of sine squared beta. So let's take it out as a common factor. So we've got sine squared beta into 1 minus cos squared beta all over cos squared beta. Okay, so from our square identity that sine squared theta plus cos squared theta equals 1. You remember I can get two other identities from this. I can get sine squared theta is equal to 1 minus cos squared theta, and the other one is cos squared theta is equal to 1 minus sine squared theta. So we have here 1 minus cos squared beta. And I know that 1 minus cos squared beta would be equal to sine squared. And that's what I'm going to change that to. So we get sine squared beta times sine squared beta over cos squared beta. And sine squared beta times sine squared beta is sine to the 4 beta over cos squared beta, which is equal to our right-hand side. So we have proved that identity. Moving on to example B. We have tan x plus sin x over 1 plus 1 over cos x equals sin x. Okay, so if we break it down, left-hand side, right-hand side. I'm going to start changing things straight away here so we don't have to keep writing out the same things, grade 11s. So here I have, at the top here, I have sine x over cos x. So I've just changed my tan plus sin x. And what I'm going to do is I'm just going to split my fraction, because you can see here we're going to get another fraction over here. So we're going to get divided by 1 plus 1 over cos x. All right. On our right-hand side, we just have sine x. So there's nothing we can really do with that. It's just sine x. I'm going to start working with this. If we're adding and subtracting fractions, we find an LCD. So remember that this is over 1. So I need to find my LCD here, which is cos. So we have cos x. Here we're going to get sine x plus sine x cos x. Okay. And how I did that was just multiplied that by cos x, multiply the top by cos x. Divided by, again, that's over 1. My LCD is cos x, so I multiply that by cos x, and I do the same to the top, so we get cos x plus 1 all over cos x. All right. Over here, I've got a common factor of sine x. Take it out. So we have sine x, 1 plus cos x, all over cos x. Over here, now I can tip and times this. Do not tip and times this. You need to get it as one fraction first before you can tip and times. So multiplied by cos x over cos x plus 1. All right, so you can see here that this 1 plus cos x will cancel with that cos x plus 1. Cos x will cancel with the cos x, and you're just left with sin x, which is equal to our right-hand side. Boom, proved. Okay, example C. We have to prove this identity, which is sine 120 degrees times cos 135 degrees times tan 240 all over cos 150 times tan 150 times sine 315 equals 3. Okay, so left-hand side, right-hand side. Right-hand side is an easy one, it's just 3. Okay, instead of writing all of this out again, I'm just going to list my quadrants and then I can reduce them. Okay, 120 is in the second, 135 is in the second, 240 is in the third, 150 is in the second, 150 is in the second, and 315 is in the fourth. If I draw my cast diagram here, all right, sine in the second is positive. So we got sine, and we reduce that by saying 180 minus that, and we get 60 degrees. Cos in the second is negative, so that's negative cos. To reduce that, we say 180 minus that, and we get 45. Tan in the third is positive, so that stays tan. And we say 240 minus 180, and we get 60. Over. Cos in the second is negative, so we get negative cos. To reduce that, we say 180 minus that, which gives us 30. Tan in the second is negative. To reduce that, we say 180 minus that, which gives us 30. Sine in the fourth is negative. And to reduce that, we say 360 minus 315, and we get 45 degrees. Okay. Now we all have special angles here, so I can use my little triangles or table method or fan method, whichever one you prefer. Okay, sine 60, that's going to be opposite over hypotenuse, so that's root 3 over 2, negative cos 45, adjacent over hypotenuse, so that's 1 over root 2. Tan of 60, opposite over adjacent, root 3 over 1. Negative cos of 30, adjacent over hypotenuse, so it's root 3 over 2. Negative tan of 30, opposite over adjacent, 1 over root 3. And negative, then we've got sine 45, which is opposite over hypotenuse, so it's 1 over root 2. Okay, let's see if some things can cancel here. Or first of all, let's work out what our signs are. So we've got a positive times a negative. As a negative times a positive, that's a negative. Negative and a negative is a positive, times another negative is a negative. So we know the whole thing is going to be a positive. So I'm going to ignore the signs now. Now this root 3 over 2 will cancel with that root 3 over 2. 1 over root 2 will cancel with 1 over root 2. And we are left with these two things here. So basically what we've got is root 3 over 1 divided by 1 over root 3. And you guys have noticed that I've ignored the signs because I've worked out what my sign is. If we're dividing by a fraction, I tip and times. So we get root 3 over 1 times root 3 over 1. Root 3 times root 3 is 3. 1 times 1 is 1, which is equal to 3, which is equal to our right-hand side. Okay, proved. Okay, grade 11s, what I would like you to do is exercise 7.8, number 1 for me, please. Thank you.